Hello and welcome to another video. In this video, we're going to be working on transpose matrix, the ninth problem in a row, I think, where we had an easy problem. And in this one, you're given a 2D integer array matrix, and you want to return the transpose of that matrix. The transpose is the matrix flipped over its main diagonal, switching the matrix's row and column indices. So in this first example, I think this picture really demonstrates it very clearly, like what you want to be doing. So if you see, this is row 0. So basically what happens here is this row 0 becomes column 0, right? Like this becomes this. And then row 1 becomes column 1, and row 2 becomes column 2. And that's essentially what you want to be doing. So you need to figure out like what your matrix should look like and where the elements need to go. So in this first example, we can actually do this. Right, so we'll take this 1, 2, 3, 4, 5, 6, 7, 8, 9, and let's actually make it over here. So let's take a 3 by 3. Here we go. And make 2 of them. So we're going to have the starting matrix and the end matrix. And then we'll have this like 1, 2, 3, 4, 5, 6, 7, 8, 9. So first of all, for your result, you can just make an empty matrix. And the dimensions of this matrix, because the transpose is flipped, if the original matrix is rows by columns, then the new matrix should be columns by rows. So in this example, it's a 3 by 3, so it doesn't matter. But in the second example, you'll kind of see what that means. So now essentially we need to figure out how we can be traversing and where we can be writing things. And so we can actually traverse, and I'll show this blue thing as a traversal. We can actually do a normal traversal where we traverse row by row, but then we just need to figure out like what index to write into. So for row 0, column 0, we'll be writing in here. But what about for row 0, column 1? So remember, this first row should map to the first column of our answer. We can actually even, no, that's fine. We can do it like this. This is fine. I was gonna say like we could do it in different colors. Yeah, actually, I think that'll make it easier to see. Let's actually do that. So we're actually gonna have each of these rows in different colors, and that'll make it a lot easier to see, like where these things map to. So we'll have 4, 5, 6 in blue, and 7, 8, 9 like this, and this is gonna make it a lot better. Okay, now, so our first row, so this green, needs to map to the first column. So we need to be traversing and we need to be writing like this. 1, 2, 3. Then the second row needs to map to the second column. So 4, 5, 6. And then this third row needs to map to this third column. 7, 8, 9. So the real question is, if we are traversing like this, what kind of indices do we need? And so let's try to figure that out, right? Like, let's say if we'll have this matrix be the original, so we'll call this like matrix, and then this is like the result. So if our item is in matrix row column, let's say, where should it go in the result? So basically, if we take a look, let's take a look at some of these items. So this is in row 0, column 1, and this is in row 1, column 0. Now this is in row 0, column 2, and this is in row 2, column 0. So it's basically just swapped. So if it's swapped, all we have to do is in here, we have to say result, column row equals matrix row column. And now if we follow this, let's do a few of these examples and make sure it's fine. So let's go over here. So if this is matrix row 1, column 0, that means the result will be in column 1, row 0, and that's correct. And then 1, 1 swapped is 1, 1. And what about this one? This is going to be 1, 2 swapped, so it should be 2, 1, so 2, 1. And then here, this is row 2, column 0, so it should be row 0, column 2, which is row 0, column 2 right over here. Then this is row 2, column 1, so this should be in row 1, column 2. So row 1, column 2, and this is in 2, 2, which is 2, 2. So that's basically it. So you kind of have this, and then you swap it. So let's do this second example of the 1, 2, 3, 4, 5, 6, and then I'll show why this needs to be like, our dimensions needs to be reversed. So here's our original matrix. And once again, we're going to draw it just like this. So 1, 2, 3, 4, 4, 5, 6. And this is why I said for your result matrix, your number of rows and your number of columns need to be swapped. So this original matrix was 2 rows by 3 columns. So now we need a matrix of 3 rows by 2 columns. So that's pretty straightforward. So we can literally just initialize. The easiest way to do this is just initialize a brand new matrix with all zeros or whatever value you want, and then we're just gonna like fill in values to override them anyway. So we can initialize a matrix with all zeros or ones or something. Okay, so now let's look through this. So this is 0, 0, so that would map to 0, 0. So that would still be over here. Now let's look over here. So this is row 0, column 1. So it's gonna be swapped. So it's gonna be column 0, row 1, which is over here. Then this is row 0, column 2, so swapped once again. So this is row 2, column 0, right, swapped. Then this is row 1, column 0, so it should be row 0, column 1, which is over here. This is 1, 1, so 1, 1. And this is row 1, column 2, so it should be row 2, column 1, which is over here. And there we have the transpose. So that's basically all you need to do. Initialize a brand new matrix with your rows and columns swapped, traverse your matrix normally, and just say whatever this index was in your original matrix, this row and column matrix, that needs to be in here in the result. And once our entire traversal is done, then we'll have a transpose matrix. And so I think this picture is really the best way to kind of see it, and also like this, I think really helps, because it's kind of hard to visualize where these things go, but if you draw it in like colors like this, I think this is like a really good visualization of where everything needs to go. And then you can kind of, for all these problems like transpose or rotate or something, you really want to figure out like how does your starting index map to your ending index and get some kind of formula there, and then use that to map everything. All right, so we now encode it up. Okay, so yeah, so we are essentially going to make a new matrix. First, we're going to get the rows and columns of our original matrix, so we can just say like length matrix, matrix 0. Then we are going to make a new matrix, and we can just make a list comprehension of, so we'll just put like zeros there initially. We're going to override all the items anyway, so it doesn't really matter. So we could say 0 for something in range. So remember, for a list comprehension, this inner array for the normal matrix would have been length columns, and then this outer array would have been length rows, right? For each row, you want to make C columns. So now we want to make it backwards. If this was columns, now we'll make this rows. And now we're basically saying for each column, we're going to make this whole thing of rows. So we're essentially taking the normal way of how to build this initial one and reversing the rows and columns. So for this in range columns. If this is a little confusing, you don't have to write a list comprehension. You can just like do it another way. But essentially what we're saying is for every single column, we're going to make a row, where normally for the normal matrix, it's for every single row, we're going to make a bunch of columns, right? So if you have like a, let's say 4x3 matrix, you'll say for every single row, I'll make 3 columns. But now we're kind of doing it the other way, where, okay, we're saying if this is our original matrix, then we're going to say for every single column, right? For every single column, we'll make 4 rows. So that's why it's like this. So we are reversing these. Okay, now we just have to loop normally through the original matrix, so we can just say like 4 row in range rows, 4 column in range columns. So whatever value is going to be, this is going to be matrix row column. Where should it be in our result? So it should be in the swapped version of our result, right? So swapped, so this should be result column row. And that's basically all there is to it. Then we just need to return the result. Let's see here what we did wrong. Indices must be integers, not list. Oh, right, this should be row. There we go. Okay. And so, yeah, once again, kind of all over the place. If you just submit a bunch of times, you'll do better. Classic LeetCode. So let's talk about the time and space. So essentially, to make this new matrix is n by m. So notice that n by m or m by n is the same time complexity, right? You're just moving the numbers around. So it's m by n there. And essentially, once we make this new matrix, which will take m by n, then we are traversing the original one, which will also take m by n. So the whole thing is just going to be this. And then for the space, we don't count the result, so it's just a one space, right? Because we have to make a new matrix. With the result, we're not using anything additionally, so a one space. So another LeetCode easy down. Can't wait for the next one tomorrow. And yeah, if you guys like this one, then please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.